Welcome back. Today we're going to talk about the fourth paper, which is the Midland Basin case study. So this one is authored by Maggie Albert from SM Energy, and they used our data and to calibrate and history matching model. It's a reservoir model, and to get a much better match and build their confidence in the model that they will use for economic sensitivity test. It's a heavily reservoir engineer application. I'll do my best to explain what Maggie did. So the first one is a problem statement, right? So now we know it's very important to utilize the capital efficiently, right? But there are so many knobs in the operator's hands. There are different spacing, there are different stacking, there are different cluster spacing, propant, right? And you can run into many different scenarios when you tweak different knobs. So that puts the importance of having a robust reservoir model allowing you to do those exercises. So the key application here, quoting Maggie from this paper, is the value of utilizing geochemistry data as a calibration tool. You have this throughout the life of the well so that you can calibrate it both from the early stage and into the life of the well, right? So that you can have the more accurate history matching, which help you to build confidence in the accurate forward modeling for different well spacing and completion design. By nature, geochemical analysis is a sample-based analysis. It does not have the ability to be forward-looking, right, to give you a prediction. However, if you use your existing data to calibrate your model can be forward-going, and that can predict you for the future into the well performance. That's exactly the application of this study. So in order to match between the model and the geochemistry data, first we need to resolve the upscaling problem, this upscaling issue, right? Because the vertical resolution of production allocation is at about 10 to 15 feet. However, the size of the beam for the model is anywhere between 5 to 200 feet. So there's a mismatch in between, which makes the artifact of mismatch between the model prediction, which is the darker blue, versus the geochemical observation, which is in the lighter blue. So after when they put into the same size, into a cumulative contribution, you see there's a much better match between those two. There are actually 4 case studies Maggie did in different areas that's showing in the map on that front page. I won't go into each of that. I only picked one of them. Feel free to go into each of that. What are the parameters she was able to tweak in order to make the match? And there's a lot of data integration goes into that to support why she's tweaking, this number versus other parameter in order to make the match. But in general, there are a lot of other data that incorporate into that. Their gamma ray, their phases, understanding different geomechanical properties. In this case, the minimal horizontal stress was the key knob to tweak that reduced the mismatch from 30% to less than 10%. This is how the model looked before and after. So this is the blue is the final match from the original, which is the orange. With the matched model, right, between the yellow, which is the geochemical data, and the blue, which is the matched model. With a matched model, we can start to interrogate and see what are the key controls to productivity, right? So here you're looking at the propant distribution. The key observation from it is that the propant distribution did not seem to follow a consistent pattern respect to landing depths. Some are 60% below the landing, while some others are 85% above it. So having a matched model, having a history matched model build us confidence in the model so that you can interrogate model using that model to help you understand both what are the key controls for your productivity, and also to helping you do all those economic sensitivity tests, right? So when you are changing your landing, changing your different completion designs, what are the EUR change, so that you can have more confidence in designing your development plan. All right, so that's all I have for this paper. Thank you for listening in.